Hello guys, welcome to my channel. Please, if you have not yet subscribed to my channel, please go back and subscribe. Okay, hoping that you have already subscribed. Now in this tutorial, we'll be talking about C programming variables. Like most programming languages, C uses and processes variables, of course. In C, variables are human readable names for the computer's memory addresses used by a running program. Variables make it easier to store, read, and change the data within the computer's memory by allowing you to associate easy to remember labels for the memory addresses that stores your program's data. The memory addresses associated with variables aren't determined until after the program is compiled and running on the computer. At first, it's easier to imagine variables as placeholders for values, much like in mathematics. You can think of variable as being equivalent to its assigned value. So if you have a variable, say I, that is initialized, set equal to a given value, or let's just say 4, then it follows that I plus 1 will equal to 5. However, a skilled C programmer is more mindful of the invisible layer of abstraction going on just under the hood, that a variable is a stand-in for the memory address where the data can be found, not the data itself. You will gain more clarity on this point when we learn more about pointers. Since C is a relatively low-level programming language, before C program can utilize memory to store a variable, it must claim the memory needed to store the value for a variable. This is done by declaring variables. Declaring variables is the way in which a C program shows the number of variables it needs, what they are going to be named, and how much memory they will need. Within the C programming language, when managing and working with variables, it is important to know that the type of variables and the size of these types. A type size is the amount of computer memory required to store one value of this type. Since C is the fairly low-level programming language, the size of types can be specified to the hardware and compiler used. That is, how the language is made to work on one type of machine can be different from how it is made to work on another. A variable in C are typed. That is, every variable declared must be assigned as a certain type of variable. So, how to declare a variable or initialize and assign a variable? What does that mean? Here is an example of declaring an integer which you have called some number. Note the semicolon at the end of the line. That is how your compiler separates one program statement from another. So this is actually a variable. This statement tells the compiler to create a variable called some number and associate it with a memory location on the computer. We also tell the compiler the type of data that will be stored at that address, in this case an integer. Note that in C we must specify the type of data that variable will store. This lets the compiler know how much total memory to set aside from the data. On most modern machines, an int is 4 bytes in length. We will look at other data type in the next section or tutorial. Okay, multiple variables can be declared with one statement, like as you can see there. So we can declare many variables in one line, as you can see there. Okay, let me also tell you something. In earlier C versions of variable had to be declared at the beginning of a block. In C99, it is allowed to mix declaration and statement arbitrarily, but doing so it is not usual because it is rarely necessary. Some compilers still don't support C99 portability, and it may because it is uncommon yet irritated fellow programmers maintainability. Okay, after declaring a variable, you can assign a value to a variable later on using a statement like this, as you can see there. So actually, the assignment of a value to a variable is called initialization, please. The above statement, or here as you can see, directs the compiler to insert an integer representation of the number 3 into the memory address associated with some number. We can save a bit of typing by declaring and assigning data to a memory address at the same time, as you can see there. So you can also assign variables to the value of other variable, like so, as you can see there. So, or assigning multiple variables to the same with one statement. So it's very possible. This is because the assignment of a given x equals to y returns the value of the assignment. Y, for example, some number equals to 4 returns 4. That said, x equals to y equals to z is really a short line of x equals to y equals to z, as you can see there. Naming variables. Also, how to name variable in C. Variable names in C are made up of letters, upper and lower case, and digits. The underscore character is also permitted. Names must not begin with a digit, please. Name must not begin with a digit. Unlike some languages such as Perl and some basic dialects, C does not use any special prefix characters on variable names. Some examples of valid but not very descriptive C variable names are. So we have there some example of C variable names. Now let us also see some examples of invalid C variables name, as you can see them. Also, there are some keywords that you cannot use to actually declare a variables. Please, some keyword like if, while, do, for, and so on, as we are going to see later. So, as the last example suggests, certain words are reserved as keywords in the language, and these cannot be used as variable names. It is allowed to use the same name for multiple variables in the same scope. When working with other developers, you should therefore take steps to avoid using the same name for global variables or function names. Some large projects adhere to naming guidelines to avoid duplicate names and for consistency. In addition, there are certain sets of names that, while not language keywords, are reserved for one reason or another. For example, a C compiler might use certain names behind the scenes, and this might cause problems for a program that attempts to use them. Also, some names are reserved for possible future use in the C standard library. The rule for determining exactly what names are reserved and what context they are reserved are too complicated to describe. So, as a beginner, you don't need to worry about them much anyway. For now, avoid using names that begins with an underscore character. The naming rules for C variable also apply to naming the language's constructs, such as function names, struct tags, and macros, all of which will be covered later. We also have what we call literals, please. Anytime within a program in which you specify a value explicitly instead of referring a variable or some other form of data, that value is referred to as literal. In the initialization, as we saw above, 3 is actually a literal. Literals can either take a form defined by their types, more on that soon. Okay, or one can use hexadecimal notation to directly insert data into variable regardless of its type. Hexadecimal numbers are always preceded with 0x. For now, though you probably shouldn't be too concerned with hexadecimal notation, so let's go ahead. Okay, this part is also very important. The 4 basic data types in C programming, please. In standard C, there are 4 basic data types. They are int, char, float, and double. The int types. What is the int type? The int type stores integers in form of whole numbers. An integer is typically the size of one machine word, which on most modern home PC is 32-bit, that is 4 octets. Example of literal are whole numbers, integers such as 5, 6, 7, 10, 11, and so on. When int is 32 bits, that is 4 octets, it can store any whole numbers integer within the range, as you can see there. A 32-bit word, that is number, has the possibility of representing any number out of this range. That's 2 to the power of 32. If you want to declare a new int variable, use the keyword int. For example, as you can see, the int, as you can see, so use the keyword int. In this declaration, we declare 3 variables: numbers of students, I, and G. G here is assigned the literal 5. Another type, that's the second one, is the char type. The char type is capable of holding any member of the execution character set. It stores the same kind of data as an int, that is integer, but typically has a size of 1 byte. The size of a byte is specified by the macro char_byte, which specifies the number of bits in character, that's byte. In standard C, it never can be less than 8 bits. A variable of type char is most often used to store character data, hence its name. Most implementations use the ASCII character set as the execution character set, but it's best to know or care about that unless the actual value are important. Example of character literal are A, B, 1, etc., as well as some special characters such as /0, the null character, and /n, new line, record the hello world. Note that the char value must be enclosed within the single quotations, please. When we initialize a character variable, we can do it 2 ways. One way is preferred. The other way is bad programming practice. The first way is to write something like this, as you can see there. This is good programming practice in that it allows a person reading your code to understand that letter 1 is being initialized with the letter A to start off with. The second way, which should not be used when you are coding letter character, is to write like this. As you can see that this is actually an ASCII code. This is considered by some to be extremely bad practice. So if you are using it to store character, not a small number, in that if someone reads your code, most readers are forced to look up what character corresponds with the number 97 in the encoding scheme. In the end, letter 1 and letter 2 store both the same thing, the letter A, but the first method is clearer, easier to debug, and much more straightforward. So, one more important thing to mention is that characters for numerals are represented differently from their corresponding numbers. That is, 1 within single quote is not equals to 1 place. In short, any single entry that is enclosed within single quotes. There is one more kind of literal that needs to be explained in connection with chars, the string literal. A string is a series of characters usually intended to be displayed. They are surrounded by double quotations. Please, double quotations, not single. An example of string literals is a hello world /n in the hello world program example as we saw. The string literal is assigned to a character array. Arrays are described later in this course, so don't worry about that for now. Okay, the third data type is the float type. The float is short for floating point. It stores inexact representations of real numbers, both integers and non-negative non-integer value. Please, it can be used with numbers that are much greater than the greatest possible. Int, float, literals must be suffixed with capital F or small f. Examples are, as you can see there. So those are some examples of float. It is important to note that the floating point numbers are inexact. So they are inexact, please. Some numbers like 0.1f cannot be represented exactly as float, but have a small error. Very large and very small numbers will have less precision, and arithmetic operations are sometimes not associative or distributive because of a lack of precision. Nonetheless, floating point numbers are most commonly used for approximating real numbers, and operations on them are efficient on modern microprocessors. Floating arithmetic is not the scope of this course, please. So you can look for if you don't know, but it's not that so important in this course. But if you know about it, is also not bad. So the float variable can be declared using the float keyword. A float is only one machine word in size, therefore it is used when less precision than a double is required. The fourth data type is the double type. The double and float types are very similar. The float type allows you to store single precision floating point numbers, while the double keyword allows you to store double precision floating point numbers, real numbers. In other words, its size is typically 2 machine words or 8 bytes on most machines. Examples of double literals are, as you can see there. If you use 4 instead of 4.4, the 4 will be interpreted as int. The distinction between floats and doubles was made because of the differing size of the two types. When C was first used, spaces was at a minimum, and so the judicious use of a float instead of double saved some memory. Nowadays, with memory more freely available, you rarely need to conserve memory like this. So it may be better to use doubles consistently. Indeed, some C implementation use doubles instead of float when you declare a float variable. If you want to use double variable, use the keyword, the double keyword. Okay, so we also have what we call, as before we stop, the size of. So if you have any doubts as to the amount of the memory actually used by any variable, and this goes for types well discussed later also, you can use the size of operator to find out for sure. For completeness, it is important to mention that size of is unary operator, as we are going to see what is unary operator later, not a function. So in its syntax is as follow, as you can see there. The two expressions above return the size of the object and the type of specify. In bytes, the return type is size underscore t, which is something as an integer. To define the header character, the header stdef.h, which is an unsigned value. So it does not have a sign, please. Here is an example of usage, as you can see there. So size will be set to 4, assuming char underscore bit is defined as 8. An integer is 32-bit wide. The value of size of result is the number of bytes. Note that when size of is applied to a char, the result is 1. That is, size of always returns 1. So guys, I hope you enjoy this tutorial. So that's the basic concept about variable in C programming, and can also be applicable in some languages. So that's the first part of variable. We are going to complete the second part in the next tutorial. Please guys, subscribe to my channel if you have not yet.